Okay, so this is going to be the introduction to the binomial distribution, and I want to go back to when we talked about the geometric. We said the geometric was a Bernoulli, so a binomial is also a Bernoulli trial situation where you have a success failure, and the probability of success is constant, and the trials are independent. All right. However, with a geometric, we were looking for the possibility, and well, let me back up for just a second. The probability of success for the binomial is still P for success, and failure is still 1 minus P, which is Q. All right? The trials are independent, so the probabilities cannot change. However, the big difference is the number of trials is predetermined or fixed. We're going to do it a specific number of times. And that's different because in the geometric, we're going to sit there and we're going to do this over and over and over again until we have the first success. And we may never have the first success. We may never find that first honest guy. All right, we may flip heads. We may never ever flip a heads. We may just flip the coin and just never become heads because we were really bored. All right, but in this case, we have a specific number of trials. I'm going to talk to 10 guys and see if one of them's honest, or 3 of them are honest, or whatever. I'm going to flip the coin 20 times, and I'm going to count the number of heads. So once again, 2 possible outcomes, but probabilities do not change. They have to remain constant, and trials are independent, but there's going to be a specific number of trials. We're going to do it a specific number of times, and the values are discrete. So this is our formula. N choose K. I believe your calculator is going to have N choose X, probability of success, and probability of failure. So let me talk about this formula here. First off, with all formulas, you'll have them on a formula sheet or you'll have access to them. N is your number of trials. Your calculator is not going to use a K, it's going to use an X, but X is the number of successes. So the probability of success, probability of failure. Now, as I mentioned before in the previous video when I talked about combinations, that right there is a combination, all right? Yes, the calculator is going to do all this work behind the scenes. So this right here is going to be your friends. And if you don't have a friend, this is your friend. It loves you, even if your parents don't. You have the calculator, which will help you out with all of this. All right, so once again, you're going to be given this formula, and you'll be given these formulas. Actually, I don't think you're given the variance, you're given the standard deviation, but if you can square this, you can get this. So real quickly, the geometric had an expected value of 1 over P. And we said that made sense because if we flipped a coin, we had a 50% chance of success, and we go, oh yeah, if we flip it twice, we expect to get a heads. Here, this one also makes sense, but it's done differently because we know how many trials we're doing. Here we didn't know when we were going to get a success. We're looking for the first one here. Here we're going to do it a specific number of times. So think about this. You're a basketball player, you make 80% of your shots, and you know you're about to have to shoot 90 times. So 90 times 0.8, you go, oh, I'd expect to make 72. So yeah, that also makes sense. This is the binomial, this is a geometric. Standard deviation is the number of tries times the probability of success times the probability of failure. So for my little example that I just did, we had 90 tries, the probability of success is 0.8, the probability of failure or miss is 0.2. Okay. Geometrics were always phrased as what is the probability of the first happening. Binomials are what is given that we're going to do this 10 times, what's the probability we have 3 successes or 4 successes? And if we have a specific number of successes, so PDF is for a specific number of successes. All right. So PDF is specific number of successes out of a specific number of trials. A CDF is going to be, we have a specific number of trials, but we want for more than one type of success. 3 successes, 4 successes, 5 successes, more than or greater than. And then, of course, we have the at least. Anytime we have at least, that should be send shivers up your spine. We know that it's going to be a 1 minus, and we're going to go into some detail on that later. Here we say, what is the probability of no more given a specific number of trials? The specific number of trials tells me it's a binomial. No more means it's, hey, it can be multiple values. It can be up to a certain value. So consequently, that makes it a CDF. All right. And then anytime we want between two values, it's always going to be the CDF of the larger minus the CDF of the smaller. And believe it or not, this actually relates back to the at least. Okay, so that's the introduction to the binomial. I know there's probably a lot of questions, but I think they'll become clear once we actually start doing some practice problems. So here we go.